Hello everyone, in this video we're going to talk about locks, the synchronization mechanism using lock variables. So what is a lock variable? Well, lock variable is a software mechanism implemented in user mode. When I say in user mode, which means no support is required from the operating system and user manages this lock variable. So how does that work? Now, lock variable is also called a busy waiting solution. Now this means that it keeps the CPU busy when technically waiting. Let me show that to you how that works. So this is a pseudocode for that. You have the entry section where there's a condition that says while lock not equal to 0, lock equals 1, and then you have the critical section and then you have the exit sections. So how it works is that, first of all, let's say there's a process, okay, process P1. If the lock value is 0, it means that the critical section is vacant, and if the lock value is 1, it means that critical section has some process which is currently running. Okay, so how it's going to work is that initially the value of the variable lock will be set to 0 over here. Okay, let's say lock equals 0. All right, then let's say there are two processes. First process comes in, sets the lock value to 0, then goes to this condition. So what's going to happen is lock not equal to 0. That's not true, it's false, which means it'll come out of this while condition. Once it comes out of the while condition, it goes to the next statement. Next statement says that set the lock value to 1. So it did that. Once it sets the lock value to 1, then it goes to the critical section over here and the process starts executing. While it's being executed, if there are any other processes come in, let's say P2, P3, P4 up to Pn, because this lock variable synchronization scheme is for multiple processes, not just for one. If any other process comes in, let's say for example P2 in this case, it comes over here. What does it say? So at that time, we are not going to change the lock value over here. The lock value is going to be set initially to 0. Then when the first process comes in, it reaches here, it will set the value to 1. So when the next process comes in, at that point, we don't need to set it again, because at that time it already has a value of lock 1. Because the value of the lock is 1, this condition is met, which means lock is not equal to 0, lock is equal to 1. So because this condition is met, it's going to stay inside this loop. So this loop will continue executing. This line of code will continue executing, and the next process is not going to be able to enter the critical section or move to the next line of statement, because this condition is going to be met at that point, since the lock value is 1 while the first process is being executed. Now, once the first process P1 finishes executing, it is going to set the lock value to 0 and then exit the critical section. As soon as it exits the critical section, because we have the other process, let's say P2, which is already in the while loop, this is continuously being executed. That's why it's called busy waiting solution, because it's keeping the CPU busy while waiting, right? It's continuously checking in this while loop. Because it was continuously checking at that point, because the first process P1 already exited, set the lock value to 0, this condition becomes then false, because lock value becomes 0, this condition is not met. That means process P2 will go to the next statement, which is here. Again, the lock value will be set to 1. The process P2 is going to enter the critical section, and then once it finishes the execution, it will set the lock value to 0. So the P3 will follow the same process. Okay, so I hope it is clear to you as to what a lock variable is and how does it solve the problem of critical section. Okay, thank you. Hello everyone. In the previous video, we learned about what are locks, what is a lock variable, and in this video, we will talk about what is a deadlock. Well, a deadlock is a situation where each process is waiting for an event to occur, and that event can only occur due to another process. So for instance, one particular process is waiting for a resource from another process. But another process is using that resource during its execution. So that particular resource is not going to be released until the next process gets finished or finishes the execution. This means that no processes can run or release the resource. Now, there are several characteristics of a deadlock, and Kaufman identified 4 necessary conditions that must hold true simultaneously for a deadlock to occur. So the next 4 conditions that we're going to talk about, all of those conditions need to be met for a deadlock to occur. First is mutual exclusion. Then you have hold and wait, no preemptive, and circular wait. So let's talk about the first one, which is mutual exclusion. I believe we have already discussed mutual exclusion several times, and it really means is that one resource should be allocated to only one process at a time, which means no 2 processes can have the same resource. If the second process wants to have the same resource, then it needs to wait for the first process to finish its execution and release it voluntarily. Okay, the second one is hold and wait. So in hold and wait, a process holds one or more resources, and at the same time, it's requesting for another resource which could be allocated to another process, right? So in this case, let's say P2, right? P2 is holding 2 resources, resource 2 and resource 3. And at the same time, while it's holding them, it's also requesting for another resource, resource 1, which is actually being used by P1 at this time. So that is your hold and wait condition. Then in no preemption, so preemption means that acquiring, okay? In case of no preemption, it says that one process cannot preempt, which means acquire another process's resource forcefully. You can't do it by force. You can't snatch somebody else's resources while it's using it to execute. So in this case, let's say P1 has been allocated a resource 1, so it's using this resource and executing. If P2 tries to request for that resource 1, it's not going to get that until P1 finishes its execution and then it releases the resource voluntarily. Okay, so that's what the meaning of no preemption is, that you cannot preempt a particular resource from another process while it's being used. You have to wait. Okay, so in circular wait, one process while holding a resource, in circular wait, one process is requesting for a resource that is held by another process and vice versa. So in this case, let's say that P1 currently has resource 2 and is requesting for resource 1. Now that resource 1 is actually being used by P2, and P2 is requesting for a resource that is actually being used by P1. So it's like a loop, circular loop. One process is requesting for a resource that is held by another process, right? So it's kind of a deadlock, right, situation. Like you can't get that until each process completes its execution, and this is never going to happen, because this is not going to release until this is not going to get released until this completes, and this cannot complete until and unless it gets this resource which is being used by this one. So it's like a circular loop. So it's called circular wait. Okay, so I hope that's clear to you. Thank you.